What is a satellite? A satellite, often spelled as satellite, is an object that orbits around a larger celestial body, such as a planet, moon, or star. In the context of space exploration and technology, the term satellite usually refers to artificial satellites that are human-made objects intentionally placed into orbit around the Earth or other celestial bodies. These artificial satellites serve a variety of purposes, including communication, weather monitoring, scientific research, navigation, Earth observation, and more. Satellites can be categorized into several types. Communication satellites. These satellites are used for transmitting television, radio, telephone, and internet signals around the world. They play a crucial role in global communication networks. Weather satellites. These satellites monitor Earth's atmosphere, collecting data about weather patterns, temperature, humidity, and other atmospheric conditions. This information is used for weather forecasting and climate research. Navigation satellites. Navigation satellites are part of systems like GPS, Global Positioning System, that provide precise location and time information to users on Earth's surface, allowing for accurate navigation and positioning. Earth observation satellites. These satellites capture images and data of the Earth's surface, oceans, and atmosphere. They are used for environmental monitoring, resource management, disaster response, and scientific research. Scientific satellites. These satellites are equipped with instruments to conduct scientific research in space. They can study various phenomena such as cosmic radiation, magnetic fields, and celestial bodies in different wavelengths of light. Space telescopes. These are specialized scientific satellites designed to observe the universe in various wavelengths of light, such as visible, infrared, and X-rays. The Hubble Space Telescope is one of the most famous examples. Spy satellites. Military and intelligence agencies use these satellites for reconnaissance and surveillance purposes. Space stations. While not traditional satellites, space stations like the International Space Station, ISS, also orbit the Earth. They serve as habitable research platforms where astronauts conduct experiments and research in a microgravity environment. Satellites are launched into space using rockets, and they remain in orbit due to the balance between their orbital velocity and the gravitational pull of the celestial body they are orbiting. Depending on their altitude and purpose, satellites can have different orbital characteristics, such as low Earth orbit, LEO, geostationary orbit, GEO, and polar orbit. What are the different parts of a satellite? A satellite is a complex engineering marvel consisting of various components that work together to perform its intended functions. While the exact configuration can vary depending on the satellite's purpose and design, here are the main components commonly found in artificial satellites. Bus or platform. The bus, also known as the platform, is the structural framework of the satellite that houses and supports all other components. It provides power distribution, thermal control, and communication systems for the satellite. The bus is often equipped with solar panels to generate electrical power from sunlight. Power system. Solar panels mounted on the satellite's surface provide a source of electrical power. These panels convert sunlight into electricity that is used to operate the satellite systems and recharge its onboard batteries, which store energy for use when the satellite is in the Earth's shadow. Communication system. Satellites use communication systems to send and receive signals to and from Earth or other satellites. These systems include antennas, transponders, and communication protocols necessary for transmitting data, commands, and telemetry. Control and guidance system. This system maintains the satellite's orientation, stability, and orbital trajectory. It includes components such as reaction wheels, gyroscopes, and thrusters. By adjusting these components, the satellite can control its orientation and make orbital adjustments. Onboard computer. The satellite's onboard computer processes data, executes commands, and manages the satellite's various subsystems. It controls the satellite's operations based on pre-programmed instructions or commands received from Earth. Sensors and instruments. These components collect data related to the satellite's mission. Depending on the satellite's purpose, it could carry sensors for imaging, spectroscopy, weather monitoring, navigation, and other scientific measurements. Payload. The payload is the primary reason for launching the satellite. It includes the scientific instruments, cameras, sensors, or other equipment required to perform the satellite's specific mission objectives. Thermal control system. Since satellites experience extreme temperature variations in space, a thermal control system helps regulate the temperature of the satellite's components. This system includes radiators, insulation, and heat sinks to prevent overheating or freezing. Structural components. In addition to the bus, platform, satellites include structural elements that provide support and protection to sensitive equipment. These may include deployable structures, mounting brackets, and panels. Deployment mechanisms. Some satellites have deployable components, such as solar panels, antennas, and scientific instruments. These mechanisms are designed to unfold or extend once the satellite is in space. Propulsion system. Satellites may carry propulsion systems like thrusters or ion engines for orbital maneuvers, adjustments, and station keeping to maintain their desired orbits. Telemetry, tracking, and command, TT&C, system. This system facilitates communication between the satellite and ground stations. It allows operators to track the satellite's position, send commands, and receive telemetry data about the satellite's health and status. Protection systems. Satellites often have shielding to protect them from space debris, radiation, and extreme temperature fluctuations. These components work together to enable the satellite to fulfill its mission objectives while surviving the challenges of the space environment. The design and configuration of these components depend on factors such as the satellite's purpose, orbit, and technological advancements at the time of its construction. If you like the content this channel is producing, please subscribe to @PagoJI TV.